Hello again, PreCal. This is the second video. I now have the correct notes. So what I'm going to do is I'm keeping this in my answer key, and then I'm telling you scroll down, and then for this part scroll back up. Okay. So what does that tell us about that function? It tells us that x equals -2 is not a 0. Okay, it tells us that we had the point -2, I forgot what it was, -9. So your graph would go through the point -2, -9. And it doesn't have, that's not a 0, that's not going to be helpful. Okay, moving on. Now we're getting to finding the possible rational roots. I made a video to explain the why behind this. So I'll post that video as the third video on the page. So the first video is that top part, and this is video 2. My why behind this will be posted below. So you could pause this, go watch the next one, come back to it if you like, but I'm going to keep going. Okay, so basically it's the factors of the constant term divided by the factors of the leading coefficient. So we can get the factors of 5 are plus or minus 1 and plus or minus 5. The factors of 2 are plus or minus 1 and plus or minus 2. So the answer I'd like to see is I get 1 divided by 1 is 1, 5 divided by 5 divided by 1 is 5, 1 divided by 2 plus or minus 1/2 plus or minus 5 divided by 2 is 5/2. Super. Okay, so then on this one I have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6 can be divided by plus or minus 1, plus or minus 2, and plus or minus 4. Okay, so this one's going to have a few more for us. I'm going to divide everybody by 1. And now I'm going to divide everybody by 2. So I now have the plus or minus 1/2. 2 divided by 2 is 1. I've already written that down. 3 divided by 2. 6 over 2 is 3, which I've already written down. And now I can divide everybody by 4. So I have 1 plus or minus 1/4. 2 over 4 is 1/2. I've already written that down. 3, I have not written down 3/4. And then 6 over 4 reduces to 3 over 2, which I already have. So that is my list of possible rational roots. So in this, number 4 would have had, what is this, 2, 4, 6, 8 possible rational roots. And this guy, what is that? 2, 4, 6, 8, 10, 12, 14, 16. Okay, so instead of an infinite number of rational numbers, you only have 16 to choose from. Isn't that great? Okay. So the next thing we want to look at is we want to state, they're going to actually use that to solve a problem. So we have here, they tell us to state the possible rational roots. So it's plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And now to be perfectly honest with you, I'm walking into this cold. I should have thought ahead, and I don't have time for that. So what we would do without any sort of a calculator, and I might ask you to show me this, is we're just going to start picking some of these rational roots and do synthetic division. So this is 1, 2, -5, -6. You know what I'm going to do? I'm going to copy this in case I in case I need it again later, just so I don't have to write it again. Let's try the value. I'm really just guessing. But I now have 8 numbers to guess from. Let's try 2. So if I say 1 times 2 is 2, that's 4 times 2 is 8, that's 3 times, oh, I got lucky. I got really lucky. This gives me 6, which gives me 0. So that tells me that was actually a rational root. Let's see. I didn't intend to be right. I really didn't. Let's see what would have happened had I picked a different number. Let's say I had picked -6. Okay, so this would be 1 times -6. This gives me -4. That gives me 24. That gives me 19, which gives me something big, and it's not going to give me a 0 right here. That's how I would know that this is not going to work for us. Okay, I'm going to get rid of all of that. Oh, well, maybe I am. Maybe I'm not. Okay, go away. Oh, that I have to do. Sorry, my bad. Okay, sorry. Okay, so I now have I have an x minus 2, and then it's getting multiplied by an x squared plus 4x plus 3. The good news is, actually, this was really good news. This becomes plus 3 times plus 1. I had a 3 out of 8 chance of guessing my rational root. Notice all of these roots, if this were set equal to 0, I can set each one of these equal to 0. I get x is equal to 2, or negative 3, or negative 1. So 3, they're all of my roots happen to be rational. Oh, that's this part right here. And there they are. Yay. Okay, so the next one, now they're saying use division to find all roots if this quartic has a quadratic that can divide into it. Okay, so if we're dividing by a quadratic, and here's what I noticed with this quadratic, it's not factorable. So what we need to do is we can't do synthetic division with a quadratic unless you can break that quadratic down to linears and then do synthetic division with a linear. But you can't. So what we'll do here is we'll do long division. So this is x squared minus 4x minus 1 is dividing into, and I like to look to see, do I have any holes? So my exponents are going 4, 3, 2, 1, 0. Okay, that's great. That's great, no holes. So I have x to the 4th plus 2x cubed minus 22x squared minus 18x minus 3. Okay, so x to the 4th divided by x squared is x squared. I like to line everything up. This gives me x to the 4th. This gives me minus 4x cubed. This gives me minus x squared. Come along. I like to change the color, change the signs, and then this becomes 6x cubed. What was that, 22? So minus 21x squared minus 18. Bring down the next one. And this will go in plus 6x when I have 6x cubed divided by the x squared. Then, let's get a new color. Then I have 6x cubed minus 24x squared minus 6x. Change everybody's sign. That's gone. This becomes 3x squared. This becomes minus 12x. Bring down the minus 3. Oh, this is encouraging. Okay, 3x squared divided by x squared gives me a plus 3, giving me 3x squared minus 12x minus 3. Oh, yay, I love it when they're exactly the same. And then this, change your signs and you get nothing. And so, okay, so here's what we have. We know I wrote really big. Hang on. No, who cares? We know that g of x is now equal to 1 quadratic times this new quadratic. And so what I need to do is I need to solve each of those. What did they tell me to do? They said use division to find all roots. Okay, so I've broken this down now to 2 quadratics, and I know what to do with quadratics. In particular, here's what I see. I see that this has a leading coefficient of 1 and an even number, and a leading coefficient of 1 and an even number. And I also notice that they don't factor. So I'm going to come along to the next page really fast, and I'm going to set each one x squared minus 4x minus 1 equal to 0. And I'm going to do the other one, x squared plus 6x plus 3 equals 0. And I'm going to complete the square on both of those because I think I can complete the square on those relatively quickly. This is x squared minus 4x plus a box equals 1 plus a box. This gives me x minus 2 squared. In my box goes 4. That's equal to 5. Square root, plus minus. X is equal to, well, okay, let me not skip that step. Just x minus 2 is equal to plus or minus root 5. And now I have x is equal to 2 plus or minus root 5. So that's half of my answer. The other half comes from over here. So now I have x squared plus 6x plus a box equals negative 3 plus a box. And this becomes x plus 3 squared. Half of 6 was 3. 3 squared is 9. That's a 9. This is equal to a 6. Square root, plus minus. And I get that x is equal to negative 3 plus or minus root 6. So when they say find all my zeros or roots are 2 plus or minus root 5 and negative 3 plus or minus root 6. You'll notice that there's 2 answers. There's 2 answers here and 2 answers there. So there's a total of 4 answers. All right. Hopefully that was helpful. Go practice.